Hello, here for this problem we want to find the angle of intersection between two planes given by their respective equations. Well, you can get the normal vectors to the two planes by the coefficient. So for the first plane, I get a normal vector is this -5, -3, 2. And for the second plane, I get my normal vector, or a normal vector is 4, 2, 4, -2. And these planes are oriented by their normal vectors, and we want to find the angle between these normal vectors. Well, we know that the cosine of the angle between these is going to be their dot product divided by product of the magnitudes. And so this is going to be what? -10 minus 12 minus 4 over square root of, well, 25 plus 9 plus 4 is 38, and then square root of 4 plus 16 plus 4, square root of 24. So the cosine of theta is -26 over square root of 38 times 24, and that means that 1 theta here is the arc cosine of this -26 over square root 38 times 24. And so continuing down here, we're going to get theta equals about 149.423 degrees if I do this in degrees mode. Of course, you can get this in radians too if you like. But this isn't actually the angle between the two planes. If this were less than or equal to 90 degrees and bigger than or equal to 0, we would stop here and that would be our angle. But if I look at these two planes on their edges here, that there's actually two angles of interest. Here, this one here is this 149.423 degrees for that angle. But actually, we want the smaller of the two angles. So I have an angle right in here, too. And so the angle of intersection here, the angle of intersection is going to be 180 degrees minus 149.423 degrees, and this is going to be 30.577 degrees, and that's our final answer.